Better this is how to convert that given. According to the increases law, we should remove this a to the power 1. It is the power of a inside of base a, and this is the power 1 is the inside of power b and outside power 3. So how to remove the bracket? In increases law, we should multiply each of the power by the outside power. We should multiply inside each of base power by outside power. Then 1 times 3. A to the power 1 times 3. Multiplying by b to the power 1 times 3. Then it becomes a to the power 3, b to the power 3. So this is the product of powers. You can see here product is powers. This is here. How got that product of powers by considering that given power of a product. Here given power 3 for the product AB. AB all to the power 3. You see another one. We can remove this bracket 3 to the power 1, 5 to the power 1. We can remove the bracket according to the increases law. We should multiply them 3 to the power 1 times outside 3. But we take it as and here 5 to the power 1 times 2. And product of powers becomes 3 to the power 2 into 5 to the power 2. Is it clear? How becomes?
Yes.
Right. Right then, you better write down this 58 number 58. Now let's see how to convert that given value into power of a product. Power of a product. Value into power of a product and product into power of a product and product of powers into power of a product. value 36. I got it as product of factor 4 times 9. And then I got it as 2 to the power 2 into 6 to the power 2 as product of powers. And then I got it as power of a product by 3 times 2 times 3 all to the power 2. Is it clear? Given in this state. You better see this how to write this 125 a to the power 3. We can write 125 times a to the power 3. Again we can write it's 5 to the power 3 into a to the power 3. Then again we can write it in 5 times a all to the power 3 and also same thing 5a all to the power 3. Is it clear? All are same. Let's see this. So here given product, right? Product given. Then we can write this 8a to the power 3. 8 we can get separated in this way and multiply it by 27 we can get separate and b to the power 3 and we can write this same thing 8 times 2 to the power 3 into here e to the power 3 times here a to the power 3 and 3 to the power 2 3 into b to the power 3. Right, you can see that here both power 3 common, then 2a all to the power 3 into 3b all to the power 3. Right, now we can take this both common power 3 for the outside and take this product as 4. Is it clear? How I got them? Right, you better write down these three words. Decimal multiplication. Then I will remind the method again. First of all, whichever value given to multiply, then it's never mind. And we can count down how many decimal places are there if you given each value or in both values. Right? Here you can see both are decimal values, then we should count down how many decimal places are there in the both values. Then here in the first one you can see there are 2 decimal places. In the second one also there are 2 decimal places. And then we could multiply 2 decimal value by 2 decimal value. Right? By that decimal multiplication method strategy. So then we count down how many decimal places are there in both values. Tell me. 4. Then we have to keep the number of decimal places in our mind, and then we could remove the all decimal points. Right, then if you remove the decimal places points here from the both values, then this becomes 25 and this becomes 92. Then we could multiply both 92 by 25 in vertical method. Right, then 5 times 2 is 10, 0 put there, 1 remain. 5 times 9 is 45, 45 plus 1 is 46. Right, 2 times 2 is 4, 2 times 9 is 18. Right, now we put add to the bottom, then here becomes 0, here becomes 0, and here 8 plus 4 is 12, 2 put there, sorry, here 6 plus 4 is 10, then 0 put there, 1 remain here. 1 plus 4 is 5, 5 plus 8 is 13, 13, 3 put there, 1 remain here, 1 1 plus 1 is 2. Then 2,300 became. Right? Now we have to keep the more decimal places for this answer from end to front. So that direction. 1, 2, 3, 4. Then it becomes 0.2300. So then we can remove the number of decimal places in the end of the decimal value. We can remove them. No need to keep them as a nursery kid, right? As a nursery kid, right? You can remove them as grade 16. Then you know that there are no decimal values in the zero in the end of the decimal value. Right? No values from them. Right? Then we could write down the final answer 0.23. That is the final answer of that first question. Did you get that method?
Yes, sir.
Right, when I will send the photo, then you better write down this correctly finally when after the class, right?
Okay, sir.
Right, then we'll see the second one. Right, second one you did it correctly, and I know I'm not going to do that second one. But I will do that third one correctly, and you didn't use any deductions in this multiplication of the fraction here in the third question. Then I will use this all the deductions in order you better see how to do this. That thing. Right, 3 over 4 multiplied by 10 over 12. Right, third question. Then here we can see there are two deductions, right? We can deduct this 3 to 12 and 4 to 10. 4 to 10. Right, 3 times 1 for the 3, 3 times 4 for the 12. Right? 2 times 5 for the 10, 2 times 2 for the 4. Right? We use all the deductions here, there are no deductions more. Right? Now we could multiply all the numerators together and the all denominators together. Then here became only 1, here became only 5, here became 2, and here became 4. Then 1 times 5 is 5. Then 2 times 4 is 8. Then 5 over 8 is the answer here. Is it clear?
Yes, sir.
I will send this on all the questions photos in order. Right? Then you better write down them in your book and do them correctly, right? And I
Okay,
will
sir.
send the activity from this part. These are the main calculations which you should know, right? The angle subtended at the center of circle is twice of the angle subtended on the circle, right? That means if this x, it should be 2x. That is the way to get that relationship. And also how to prove it. So here I got another figure here to explain that. First of all, we should connect with P and O and should reduce that side until D here. Right? Then you could see, if I name this angle as x here, this angle also x because of, rectangles are equal in a same circle in length. Right? All the rectangles are equal in a same circle in length, right? Now, if I take this as x because this is also x, why? In isosceles triangle, the angles opposite the equal sides are equal. If this angle x, then this is the angle of this opposite side, and also this is the angle of this opposite side. If both angles are equal, then I will name them as A because I got here x now. If this angle A, this is also A. In that relationship, I could write down this as x and also this as x because CO and OA are rectangles in this circle. Did you get that?
Yes, sir.
And also, if I name this angle as y, right? You could see if it is y, so I can name this as also why? Because same theorem, isosceles triangle, the angles opposite the equal sides are equal, right? And also now we can see this whole angle becomes x plus y, right? And I got that whole angle as this ACP angle becomes ACB angle becomes x plus y. Then we are going to find out that AOB angle, right? I will take this both 2x, right? Then here also x and here also x, it becomes 2x. Then you can see this, how that relationship becomes. If this both angles x magnitude x, then here exterior angles become 2x. Then what is that relationship in the triangle? So it is one of basic theorem in the triangle. So how to explain it? When the sides produce in a triangle, the exterior angle formed is equal to the sum of two interior opposite angles. Two interior opposite angle sum is equal to the exterior angle formed when the sides produce in a triangle. Did you get that?
Yes, sir.
Right. If we take the relationship in here, we could easily come this as 2x because the 2x plus x equal to this 2x and this y plus y becomes 2y. Then you can see that whole AOB angle, this angle becomes 2x plus 2y. The 2x plus 2y means we could take the common factor 2 for the outside of the bracket, then it becomes 2 times x plus y. Then that is the angle of this AOB. And then you could see that ACB angle equal half of the AOB angle, and also that AOB angle is equal to twice of this ACB angle. Did you get that? How to prove that relationship?
Yes, sir. Yes, sir.
So this is the geometrical theorem. Then how to prove it? If you have to prove it in an exam or area, then this is the way to show that step by step that your statement according to the geometrical relationship step by step you have to prove them. But I am not here mention any theorems, but you have to show a bit of reason why you should use this and what is that reason. You have to write down this bit of relationships. And here I used to the relationship. One of that I got that isosceles triangle relationship. The angles opposite the equal sides are equal in an isosceles triangle, and also I use this here triangle relationship, exterior angle relationship. So the exterior angle form is equal to the sum of the interior two opposite angles when the sides are in a triangle, right? That is the next theorem I use, and also I use here this whole relationship to show that that AOB is twice of ACB, right? AOB is 2 times ACB here. That is the thing we proved here. Did you get that, my point?
Yes, sir.
Right. Okay, hurry up then write down this step by step.